ಮನೆ ಒಳಗಡೆ ಆಯ್ತಾ?
Okay. Good evening, everyone who are joining in. I am Anmol Monoli, a co-team member at the GDSE CIT. I welcome you all on behalf of our team for the day 2 of Python for Data Science Bootcamp, as we continue to explore the world of data science. The agenda for today is that I'll be starting off with NumPy, and followed by Pranav Durai, who will be explaining about matplotlib. And then we'll wrap it up by building a model and doing data analysis on a data set. And we will build the model using the 3 libraries that we learned in this bootcamp, which are pandas, NumPy, and matplotlib. I hope that you take away some good insights from this bootcamp. So without any further ado, let's start the session. And I also hope that all of you have installed Anaconda Navigator or the Anaconda environment and are ready with the Jupyter Notebook, because I'll be doing hands-on session. And also feel free to ask any doubts or questions, drop it in the chat box. Either me or the core team members will try to answer them. Okay, let's start. So I will be covering NumPy. So NumPy stands for Numerical Python. It is a fundamental package in Python used for scientific computing. Now, this was created in 2005, and it's an open source library, which means it is free to use. And this NumPy library is mainly used to perform array operations. And there are, of course, many other features like mathematical and logical manipulation, statistical operations, selecting, sorting, linear algebra, and random simulation. Random simulation is where we introduce randomness into our project. For example, we want to generate a random number in the project, then we just call the random function from the NumPy library, and that will do the job. Now, most of you might have this question in mind: why do we need to use NumPy? I mean, most of these features or functionalities can be done using just the traditional Python code. But why do we need to use an external library like Python, NumPy? So I'll try to answer that. The reason is Python lists can serve the same purpose. but the fact is that they are slow to process. When you deal with large data sets, the code becomes complex and it'll take more time and memory. Now, at the core of NumPy package is something called ndarrays, which is an object of the NumPy class. Now, this ndarray stands for n dimensions array. And let's actually do a difference between ndarray and a list. Now, ndarray consumes less time and memory to perform an operation, whereas lists take more time and memory. ndarray supports n dimensions, which means it can have 1 dimension, 2 dimensions, 3 dimension, and it can have any number of dimension arrays. On the other hand, lists only support for 1 dimensions. And another difference is that ndarray supports advanced mathematical operations on large numbers with less code. Whereas in lists, it becomes complex when we deal with advanced mathematical operations. And another fact is that ndarray, it has a continuous storage in memory. Hence, the access is faster than lists. On the other hand, lists are stored in a non-linear fashion. So we can clearly say that the ndarray is the winner here. So yeah, now let's actually test this out. Let's do a practical analysis between ndarray and lists. Let's head on to the Jupyter notebook. Feel free to code along with me. And if you have any doubts or any queries while running a Jupyter notebook, always drop it in the chat box. Now, if you're ready with Jupyter environment setup, I would like to hear a ready in the chat box. Please type in ready. Okay. Okay, it's very nice. Okay, let's create a new notebook. Click on new and Python 3. There we have a new notebook. And let's actually let's do a difference between the array and list. So the two main features which stands out is the time and memories usage, right? So let's check how much time does ndarray take and how much time does a normal list take. So let's import some libraries. Let's import NumPy as np. np is the alias name given. And we also import something called system. The system is to get the parameters to check memory. And let's call s a variable, and let's call range 1000. Now this generates 1 to 1000 numbers. And let's print size of list in bytes. We call system dot get size of s into the length of s. So let's run this, and we see that it takes about this much space. And let's do the same for using ndarrays. let's call a variable as d and do np.arrange. This is the same functionality as range in Python list. So it basically does the same, where we have 1 to 1,000 numbers. Let's do size of array in bytes. And here we give d.size into d.item size. So you can see that it takes less amount of memory when compared to Python list. And I did mention that we write less code than compared to Python list using ndarray. Let's make a small program. Let's let's consider two single dimensional arrays, and let's multiply each element by element and check out the difference between the two. So also we can also do like a time analysis.
ईमेल का है, फीमेल जैसा नहीं है.
Let's do an import of time to keep track of how much time does it take using Python list and ND arrays. And let's say we have two lists containing 1 and 2, and then B containing 2 and 4. And we have C, which will just initialize it like this. Now what we expect from this is that 1 into 2 must give us 2, and 2 into 4 must give us 8. So this should be our expected result. Now let's do initial time. Time. So this basically starts taking note of the time when we do an operation. And in the usual practice, when we use Python list, we usually use a for loop for I in range of length of A. We can use A or B because they are of the same length. And then do C dot append, and then A of I star B of I. So this should give us the result. Now let's print out that the solution using and let's also calculate the time taken. Format here we call C and time. This is to calculate the difference in the time when we started before the operation and the current time. There seems to be an error. Print verify. Yes, I must. Yeah. So you can see that the answer is 2 and 8, 1 into 2 and 2 into 4. And this matches the time taken. Let's do the same operation using ND arrays and check out the difference. Now we used ABC, right? So let's use def. D is equals to np dot array. Let's pass in the same. Now, this is the difference. Instead of using a for loop, here comes the concept where we can just say a variable called f and just do d into e. This is the advantage. This gives us the same result as of this. Now, this removes the need for an external loop. So there are two concepts that comes into picture here. One is called vectorization, where we essentially remove the external looping structure and just include a statement like this. And the other is broadcasting. And yeah, let's print the same. Yeah, so we get the same result using just the single statement instead of a for loop. Now, since this is a very small operation, the time taken by the Python list and the ND array is almost the same. See, again, it depends on the time. Here we get 10 to the power minus 5. So when we deal with bigger data sets, this seems to be faster in giving us the solution when compared to Python lists. Okay, let's head back to our presentation here. So I hope you understand the difference between ND arrays and lists and how ND arrays are useful when we deal with data sets in data science. I see that there are. Okay, have you guys installed NumPy? If you're using an Anaconda navigator, it will be installed. And it's arranged for it is called arrange. I didn't get the time output for the traditional Python. Can you be more specific, Vishwa Patel? Where did you get an error or something? And of course, we'll be having a Q&A session in the end where we can answer the remaining doubts. So let's move on. Now, let's deal with the various features associated with NumPy. The first is the ND array. Let's learn how to create. We actually created one. ND arrays it only accepts homogeneous elements. And we have dimensions which are termed as axes in ND arrays. So if it's a one dimension, it's just a 1D array. And again, it depends on the number of axes present in the array. You have the different dimensions. And let's demonstrate this. Okay, we have already imported NumPy. So the syntax is simple. We call in a variable name, and then we type np.array. This is the function to create an array, ND array. And then we pass in a list or a tuple. It can be anything, any array sequence. and it will convert into an ndarray for you. And then let's print array. So this is converted from a list into an ndarray. And now let's check the type. You can see that it says the NumPy class and the ndarray is the object. Now we have different dimensions. We have 0 dimensions, we have 1 dimension arrays. So let's test out 0 dimension. Let's say array is equals to np.array. And then let's type a number like 42. Now this is accepted. This is called a 0 dimension array. Now there's actually a function called ndim, which gives us the dimensionality of a particular array. So let's test that out. Array dot. It's called ndim. So you can see that it says 0. Now, if we change this and pass in a list, let's say 1, 2, 3, and let's run this again. It says 1. Now this is a 1-dimensional ND array, and now if you want to create a 2-dimension, then all that we have to do is pass one more list. Let's say 4, 5, 6, and this should be taken as 1. You see that this list contains these two nested lists. So dimensionality is essentially a nested list. You can see that it's 2. This procedure you can do with multiple dimensions. So this is the advantage of NumPy. Okay, let's head back. Now let's discuss about array indexing. How do we access ND array elements? Now the index is how we do with normal arrays. You can access an array element by referring to its index number. So for example, when we declare a variable called arr and create an array, we just print out the index. So when we print out the array of 0, we get 1. Let's do that. Let's create another array. Let's pass 1, 2, 3, 4. Now, if we print C of 3, it should give us 4, which is the same as array in other programming languages. Now we can also add multiple the indices, the numbers present at certain indices. For example, let's say C of 1 plus C of 2, which gives us 5. Now it's 2 plus 3. So that is again, that can be done here. And now when we deal with dimensionality, we want to know how to access the elements in a 2D array, a 3D array. So in that case, let's consider array with 2 dimensions. let's say 1 and 2, and then 3 and 4. So this has 2 dimensions right here. And now when we want to print a certain array position, we take in the array, and inside the brackets, suppose let's assume we want to access 2 in this 2-dimensional array. So how we do that is we look from the exterior. So this nested list is at an index of 0. So we write 0, comma, and 2 is present at the index of 1 in the nested list. So we write 1. We write 1 here. So this, so this gives us the 2 in the 2-dimensional array. Similarly, you can access multiple things. And the same goes with 3-dimensional arrays. And now here, we can also access, okay, let's use a 2-dimensional array instead. We can just use a negative indexing as well. So let's say -1. This gives us the same answer. Okay. Yeah, we can just use comma separated integers representing the dimensions and the index of the element. So here, again, 2 is at the index of 0 and then 1. Now let's perform array slicing. So what slicing exactly means is that it means that taking elements from one given index to another index. So we use a format like start and end step. Start marks the first index where you want to slice the array, and then end is the last index, and then step marks that whether we want to jump elements. When we do this procedure, if we don't pass the start, it is always taken as the 0 index, and if we don't pass in a value for end, it automatically takes the length of the array in that dimension. And if we don't specify step, it is taken as 1 by default, which means that let's consider this example where we have an array and there's a list. So if we have a step of 1, it would essentially print all the elements present in the array. If we take a step of 2, then it will skip 1 and then print. So it'll print 1, 3, 5, and so on. Now let's test this out. Let's consider print array. Now we slice it from 1 till 2, let's say 3. Okay, so it gives us 2 and 3. So 2 is at an index of 1, and then when we specify end, we don't usually consider the value at that position. So at the index of 3 is 4, but we don't consider 4. We stop at 3. Okay, and yeah, this is pretty much it. Now let's see the different data types in NumPy class. We actually have many more data types than the Python library standard one. And we usually represent these data types using a single character like I for integer, B for Boolean, and so on. And we have new data types like time delta, date time, object is there. Then we have Unicode string, where suppose we deal with multiple languages. Unicode represents a code for different languages. So these are the various data types present in NumPy. And yeah, the NumPy array object has a property called dtype, which tells us what type the array is, what type of values are present in the array. So let's say this. Let's consider this example. Array is equals to NumPy array, and then we pass in a integer list containing integers, and then we specified a dtype as S, which stands for string. So what this exactly does is it converts these integer elements into a string. So let's test this out. There's 1, 2, 3. Okay. Then we print. You see that we have 1, 2, 3, and 4, which are converted into strings. And now let's print the data type. We see that it's S. Now this condition holds true only for certain certain operations, like to convert integer to string. But there are certain cases where we cannot convert any a string into an integer, and that will throw a value error. So that is not possible. On the other hand, we can convert floats to strings. That is possible. The best way to change the data type of an existing array is to make a copy of the array with the asType method. Okay. Let's actually consider this example. Let's do that asType. Array is NumPy. Let's take in some float 2.1. And let's make a copy. Let's call it as new, and then array.asType. And let's convert it into an integer. So we print new, and let's also print the data type. Okay, we see that it's converted from a float to an integer using the asType function. Okay, so this is done. Now there is again another feature called shape and reshape in the NumPy class. So what the shape is an array is the number of elements present in each dimension. Okay. So yeah, NumPy arrays have an attribute called shape that returns a tuple, with each index having the number of corresponding elements. So let's consider this example. Array is equals to NumPy array, and we have a two-dimensional array here. And let's test what this example gives us. We have taken 1, 2, 3. Okay. And let's print the array shape. We see that it is 2 and 4. Now 2 represents the number of subsets, and 4 represents the number of elements present. So that gives us that. And we can also reshape, which means we can add or remove new dimensions or change the number of elements in each dimension. So this is possible. Let's see, look at this example, array as NumPy array, and then we just have a single dimensional array. And then let's say we want to reshape it into 4 subsets having 3 groups, 3 elements in each thing. So let's test this out. Then we essentially create a copy of it as a new. And we call in the array shape. Here we specify, let's suppose 4 and 3. Let's print out the new. Tuples. Okay, so I forgot to give reshape here. Yes, so you can see that there are 4 subsets with 3 elements each. So this is useful when we want to convert our data into different dimensions. And yeah, so this is also a very good feature that we can flatten out a multi-dimensional array into a single dimensional array by just calling reshape -1. So let's do that. Let's say new. You can see that the array which was into 4 dimension now has become just a single dimensional array by just passing this condition statement. But imagine if we did the same using Python less, it would have taken so many for loops, and the code would have turned out to be very complex to read as well as to understand, So this NumPy library is very much useful when we deal with, mathematics. So let's proceed on to array iterating. Iterating means that going through elements one by one. We can do this in multi-dimensional array using the for loops, or we have a built-in library called the ndarray. Now, this is a very useful function when we deal with advanced iterations, especially when we want to iterate through multi-dimensional arrays. Now let's see how we would iterate using a normal for loop. So we have an array np.array. Let's pass in some list, and that how we iterate is by using a for loop. Let's say add, and then we print out x. So this is the normal procedure, but when it comes to two-dimensional, as the dimensionality increases, let's say 4, 5, 6, should be in. Then we can print out this, and this gives us this. The thing is, when we deal with higher dimensionality, the for loops, the looping concept, it takes a lot of time and memory. Instead, we have something called, and also if we want to notice that here, when we print this, it is printing as separate arrays. But when we want to access individual element in a particular array, then we will require nested loops to print either 2 or 3. Instead of this, we can just perform a simple function called nditer using NumPy. Let's check that out. Let's consider another example, array as let's consider 1 and 2, 3 and 4, and let's make this as 1. Let's use this. Now we can just do for loop for x as a iterable variable in np.nditer. Then we pass in the array. Let's print x. Now you can see that using just the single line, we can access each and every value within which is included in n dimensions. Whereas if we were to use the normal looping structure using for loops, then we would have created multiple nested loops. But here the nditer takes care of that. And now, in basic for loops, iterating through each scalar, which is essentially the single element in a subset of an array, we need to use n for loops, which can be difficult to write for arrays with very high dimensionality, which is exactly what we demonstrated. Now, it is also possible to iterate with different stepping size. So let's understand what does this exactly mean. Let's take in an array, np, let's say 1, 2, 3, 4. Let's make this as a now if we perform a for loop in np.inditer array, and now we just specify like this, and we print x. So what this exactly does, let's look at this. Now here we mention the step size is 2, which gives us the values of 1, 3, 5, and 7. Notice that this is a very helpful operation when we deal with multiple dimensions. So if we were to use a normal Python list, this would have taken so many lines of code. But using just this, we can just access any element in an n-dimensional array. Okay. And now let's understand how do we join NP arrays, NumPy arrays. Joining is basically putting together contents of 2 or more arrays in a single array. We pass a sequence of arrays that we want to join using the concatenate function. And we mention the axis, which is basically the dimension where we want to join. If axis is not explicitly passed, it will be taken as 0 by default. Okay, let's demonstrate this join function, joining concept using concatenate. Let's call this array 1 and then make it an ND array. Let's pass 1, 2, 3. Then let's take array 2, make it as an ND array. Let's see 4, 5, 6. Now, if we want to join these two arrays, we use something called concatenate. And we pass in the array 1 and array 2. And then we print out the array, the updated one. You can see that they are combined. So this can be achieved with the help of concatenate function. Now suppose we want to join a two-dimensional array, then how would we do that? Okay, let's consider array 1 as so this is two-dimensional array. Let's make this as 5, 6, 7, and 8. Now let's concatenate. Now we pass in array 1 and array 2 along with the axis. We mentioned that we want to concatenate using a different dimension, which is 1. So let's print that out. Now see that 1, 2, 3, 4 comes here, and then 5, 6, 7, 8. So this is, let's consider the horizontal axis as the axis number 1. So it joins left and right. Okay, I think this might require a little bit of explanation. Okay, Let me demonstrate that. Okay, here we have taken 1, 2, 3, 4, right? So let's use MS Paint. So we have 1 and 2 here, and 3 and 4 here. So these are the two dimensions. And then we have 5, 6, 7, 8, which is essentially looks like this. Now, when we call axis 1, it is essentially joining here. So we get 1, 2, 5, 6, 3, 4, 7, 8. But when we change the axis to 0, let's see what happens. We get 1, 2, 3, 4, 5, 6, 7, 8, which means that this part gets attached down, which concatenates through this axis. So this is what happens in the background. So this is the need for to use the axis here. I hope you understood that concept. Okay. Now stacking. Stacking is the same as concatenation. The only difference is that stacking is done along a new axis. So let's take an example. Here we have. Okay, let's consider the same example here. And close this. Let's call array 1. Let's pass 4, 5, 6. Now array we create by this is let's use np.stack and then array 1 and array 2, and let's also specify the axis as 1. Let's print. Now you see that this is joining. This is basically stacking one array on top of another. So we get 1 and 4, 2 and 5, 3 and 6. So this is the difference between concatenation and stacking. And we also have certain built-in functions like horizontal stack, vertical stack, and depth stack. And we can also split NumPy arrays where we have a normal 1D array, and then we want to split it into three arrays. Let's take the small example. This is basically the opposite of joining. Let's consider this example. Okay, here we use the built-in function called array underscore split. And then we pass in the array which we want to split and the number of splits we want to have. Let's consider 3 here. And let's print out array. Okay, sorry, you have to print out new, right? So you can see that we have 3 different arrays having 2 elements each. If the array has less elements than required, it will adjust automatically from the end. So what this means is that let's consider one example. Okay, when we have here, let's consider we want 4 or 5. Then, yeah, see, when we specify that we want 4 splits, but here it will be uneven as it will split 1 and 2, 3 and 4, and it will automatically split the remaining elements from the right hand side into separate arrays. So that's what this exactly means, the statement. If array has less elements than required, it will adjust from the end accordingly. Now let's cover the concept called searching. You can search for an array, search an array for a certain value and return the indices that get a match. To search an array, we use the where method. So let's consider this example where we have array as the NumPy ND array, and then we have a sequence where we have multiple 4s here. Notice that. And then we call in a variable and pass in the where function. And we are specifying a condition that we want the indices where there are 4 present in the array. So let's test this out. Let's give anything. We can give 3s, 4s. And the method is called np.where. And we want to give a place where, let's give 3 no, because it has multiple 3s. Let's print x. So it gives us 2, 3, 5, and 6. Notice that the first 3 is here at the index of 2, 3, 5, and 6. So this does that. Yeah. And there's also a method called search sorted, which performs a binary search in the array and returns the index where the specified value would be inserted to maintain the search order. So let's understand what does this exactly mean. Let's consider one more example. See, because I'm considering so many examples because NumPy it can look a bit overwhelming when we consider so many numerical operations. Hence, it'll be better understood if we, understand this NumPy library with multiple examples. So let's consider array np.array. That's person 6, 7, 8, 9. np.search sorted. And then we pass in the name of the array, and then let's find 7. And then print, let's include 7, sorry. So this is the number which can be inserted into this array at a certain index. Let's print x. Now, what this exactly does is that once we pass in 7, it looks for a position in the array such that when we insert this 7 into this array, it would not disturb the structure of the ascending order, since it's a sorted thing. Now let's say I want to insert something like 10, then it would just put this 10. It would return 4, telling that you can insert 10 at the end of the array. But if we tell something like 5, it will tell that you need to insert 5 at a position which comes before 6. So this is the functionality of search sorted function. Okay. Now sorting arrays. Sorting is basically putting elements in an ordered sequence. The NumPy ndarray object has a function called sort that will sort in a specified array. In this example, array as an nd array, we have 3201, and then we call in the np.sort array, pass in the array. Let's just do this quickly. We need to print it out. And you can see that it's already sorted. So this is a built-in function within the NumPy class. Note that this method returns a copy of the array, leaving the original array unchanged. So what that means is, even if we call the sort function, the original array remains the same. It only creates a copy while sorting. And you can, of course, sort any dimensional array. Let's test it out with a 2-dimensional array. And also you can sort strings, you can sort Boolean array. It need not be restricted to only integers. So if we let's consider a string array where we have array as, and then we pass in some strings. Let's say apple, the fruits, banana, and mango, and apple. So what we have is a list of the nd array having the contents of string data type. Okay, let's print np.sort. We'll pass in the array. Now this sorts according to the alphabetical order. Now this can also be done on a Boolean array. Now I have a question for you all. So if I have an array, let's say I have an array something like this, a Boolean array which has true, false, true. Okay. Now, if I print np.sort function on this array, what would I get? You can type in the answer in the chat box. Yep, correct. Vishwa Patel and SVSS, they got it right. Yes. It prints false because it has the value of 0 essentially, and true, which is equivalent to 1 and 1. Now, as I told before, let's just sort a two-dimensional array. Array is np.array, and then let's pass something like 3, 2, 4, and then 5, 6. Okay, 0 and 1. So yeah, let's print this. Now look at this. It sorts according to each subset, each nested dimension. So this is pretty useful, right? When we are dealing with, so many data which are present in a structure like matrices, and we want to sort. It's not possible to sort each and every dimension separately, right? So it proves to be useful there. And we can also filter arrays. So getting some elements out of an existing array and creating a new array out of them is called filtering. So in NumPy, you filter an array using a Boolean index list. If the value at an index is true, that element is contained in the filtered array. If the value of at that index is false, then the element is excluded from that filtered array. So let's consider this example where we have a single dimension array. We specify a Boolean index list called X, where we specify true, false, true, false. Okay, let's just print this and check out what does it exactly print when we give new array. Then we pass in Boolean array. Can be okay. False. And then we assign this Boolean list to a new array. Then we print out new array. Now notice that wherever it is true, it prints out that. Here it is true in the case of 41 and 43. In case of 42 and 44, it is false, so it doesn't print. So this is the functionality of filtering arrays using a Boolean index list. Now we are done with ND arrays. Now this is another functionality in NumPy class where we can generate pseudo-random numbers. I don't mention it as just random numbers because even for generating a random number, there is some algorithm running at the backend. So it is not exactly generating, randomly. You can also generate a true random number by accessing it from an external source that we can classify as a true random number. But when we generate using an algorithm, it is turned as pseudo random numbers. Now NumPy offers the random module to work with random numbers. So when we call in X as a variable and we call in the random function and we specify rand of integer type, and here 100 is the range. the maximum range where it can generate the number. So let's test this out. X. X as random. Okay, first, since this is a random module, we'll have to import that first. So, this is present in the NumPy class, so there's no need to install it separately. We just call in NumPy, from NumPy import random. Let's run this. And then I think it was 100. Yeah. Let's call in a variable and let's say random. And then random integer of 100. Okay, let's print. So it prints 30. When we run it again, it prints 1. So it keeps generating random numbers. Now we also can perform a random data distribution. Okay, look at this example. X is equals to random.choice, and we have a list, and then we have, this is the probability distribution, where it says that 3 can occur at a probability of 0.1, then 5 at 0.3. So this is the chance of occurring of these values. So let's just print this out. Random.choice. Choice is basically a function to select a particular given value, a particular value within the set. Here we consider 3, 5, 7, and 9. And then we pass in the p as 0.1. Can be anything. And then we mention the size, which is basically the range. Then we print. Random. Okay, somewhere here. Right. Random choice. Okay, here's a mistake. Oh, it should, by the way, it should, all these probabilities, they should sum up to 1. So here it was 1, 3, 6, and 0. So I just neglected that. Now look at this. We just get a list of 100 numbers based on the probabilities mentioned. So we can see that probability of getting number 7 is almost 60%. So we can find more of 7s in the list. So this is the functionality. So I'm done with the NumPy class. If you have any doubts or questions, you're free to ask. Yes, SVSS. All the probabilities should add up to 1. Guys, if you have any doubts or queries, I'll be free to answer. I'll be available. print solution time. Okay. Initial time. Okay. Vishwa Patel, did you take into the, did you consider the initial time before starting the operation? Okay. Okay, I'll try to figure that out. In the meantime, I'll be handing over the session to Pranav Durai, who will be explaining about a very interesting library called Matplotlib, where we get to deal with variety of graphs. Yeah, I will get back to you. I will message you, Vishwa Patel. Let's find out where the error is. In the meantime, Pranav, you can continue.
So guys, we'll be having a 3-minute break, after which I'll be continuing with my session. So we'll see you after the break. Please be back in 3 minutes. I'll put a timer on the screen. Thank you.
Yeah, sure, Pranav.
Anmol, could you stop sharing the screen?
Yes.
So welcome back, everyone. A very good evening to everyone present here. My name is Pranav Durai, and I am a core team member at CIT Bengaluru at GDSE. And today I'll be explaining about this Python library known as matplotlib, which is also a powerful data representation library. So let's dive deep and get to know more about this, right? So let's start with what is matplotlib. Okay, so what is it? Matplotlib is easy to use and an amazing visualizing library in Python. Okay, so let's say that you have a very large data set and you want to be able to represent all of that data visually, as in a pictorial manner. So matplotlib is the go-to library for just that, right? And we do know that matplotlib is built on top of NumPy array, and it is designed to work with broader stacks of data, which means it doesn't care if there is less data or more data. It will definitely be able to visualize the entire stack, right? So it consists of several plotting types such as line, bar, scatter, and histogram, right? So there are multiple ways in which you can visualize your data, and matplotlib is going to help you to do that really efficiently. Okay, so let's jump in and see what are the interesting stuff that you will learn today. So we will first start with what is pyplot and how to use it. We will explore some stuff about figure class. We will see how to use access class. We will see how to perform multiple classes. We'll also see how to create 3 different types of plots in this session, for example. And we'll be using the line chart. We'll be showing the bar chart, and also we'll be checking out the scatter plot, right? So let's start with the first one, which is pyplot. Okay, so what is pyplot? Pyplot is a module in matplotlib that provides a MATLAB-like interface, right? MATLAB is nothing but a numerical analysis-based software or a tool, and you can learn more about it on the internet. Just give a Google search and you'll get more information about it. But it's mainly like something where we visualize some data and we perform some operations on it. Okay. Next, it provides functions that interact with figures. You can create a figure, you can decorate it with labels, you can create plotting area in figures. Okay, so that is everything about pyplot. So let's jump into a new Jupyter notebook, and let's check out how to use pyplot. Okay, so I have opened up a new notebook over here. You can either continue with the same notebook, which was created by Anmol, or you can create a new one and name it as matplotlib, just for your reference. Perfect. So let's start with pyplot. So just like how we imported pandas yesterday and how we imported NumPy today, we have to import matplotlib so that we can use its modules and components, right? So let's type in import matplotlib .pyplot. Okay, and the alias which I'll be using here is called PLT. You can use whatever you want, but PLT sounds standard for it. Right, so let's start with the first construct over here. Let's say PLT.plot. So you want to plot a graph, right? So let's give it some values, and you want to give it some values in the form of a list over here inside. So let's say just a simple example over here, 1, 2, 3, 4, and let's give in some other values, right? So let's make another list, 1, 4, 9, and 16, right? So to shift enter, and there you go. You get the entire graph, which is created from this values that you give over here, right? given the X values and given the Y values, it plots a graph as per the inputs that you've given in the pie plot, in the plot construct over here, right? This is a 2D line. Next, you can either do this or you can start with another one over here. Let's say you want to give some axes over here. Okay, so let's say plt dot axis, right? You want to give some axis, and let's give it some values as a list. Right. So this is the empty axis with these values, right? So what if I want to combine both of this? So just say plot plt dot show, right? So we have the entire graph over here. One more thing is sometimes Jupyter Notebook messes up with matplotlib, so it's always safe to try it in similar cells, as in the same cell. Okay. I'll remove these. And there you go. This is the final graph that we want to get out of the inputs that we've given, right? So we've given the inputs in the form of plot over here, and we give the axis values over here, and we say plt.show, and this will display the graph as it is. Okay. So this is just an example for the pyplot library. So let's go and see what goes pyplot function. Okay, it's a module, and let's go to the figure class. Okay, so what is a figure class? Now you see over here that the figure class is the top level container that contains one or more axes. Okay, next, it is the overall window or the page on which everything is drawn, right? So you have a figure, and within which all of the drawings of the graphs is contained. So basically the figure class acts like a container, and all of the data that is required to represent the graph contains within that container, exists within that container, and the figure class makes sure that you can represent it as a figure in the end, right? So let's see an example for this one also. So let's jump into our Jupyter Notebook. Let's make a new comment and say figure class. Right. So let's check figure class. Now, just as we imported matplotlib over here from pyplot as plt, we would also require another import for figure, and it is as follows. Just follow it with me. So from matplotlib dot figure, I want to import figure, which means from this library file, I want to import these figure module. Excuse me. Right. So first, now let's say that I want to create a new figure which has a width of 5 inches. Okay, so I will put the requirements over here. I want the width as 5 inches, and I want the height of the figure to be 4 inches. Right. So these are the two requirements that I need to make the figure. So this is just an example. So what I'll do, let me create a new variable called fig. You can name it whatever you want, but this is just how I'm doing it. So let's do plt.figure. Right. So you want to access that. And let's pass in some parameters into this construct. Right. So let's say the figure size, the fig size. Right. So fig size is equal to, and I pass those two values for the width and for the height into this fig size construct over here. So let's say 5 and 4. Right. So it is done. It is done with creating a figure size, which is the figure size. Right. Next, let's say that I want to add access to it. So I will create access for this. Let's do ax is equal to fig dot add underscore access. This is the construct that you need to use. And let me give a very basic access over here. So you can see the empty graph over here based on the requirements that we have mentioned in this previous command, right? So let's add in some values into it so that we can see the final representation. So let me say ax dot plot. So you're passing some values into the ax variable that we created, which also has the access over here. And let's pass in some values into it. Okay. So let me give some random values. 3, let's say 4, 5, 5, 6, 6. Okay. So x values. Let's give y values. 5, 7, 1. So just some random numbers just to show you guys. 4, 6, and 8. Right. Okay. So this is just some random values I'm passing to plot the graph. And let's say plt.show. So this will help you to display the graph with the given values. Right. So you can see that the figure class has helped us to make a figure with 5 inches of width and 4 inches of height. It is confined into this figure construct over here. And it has plotted the graph based on whatever numbers, based on whatever values that we've passed into this construct here. And using plt.show, we're able to see the graph in the end, right? So this is figure class in Matplotlib. So let's jump into our slide and go to the next one. So access class. So I was using the term access in the previous slide. So this will give a kind of a justification to what that is, and we'll explore more of that in this particular slide. Okay, so what is it? So access class is the most basic and flexible unit for creating subplots. Okay, so what you do over here is, any given figure may contain many axes. Okay, but a given axis can only be present in one single figure. Okay, and the next thing is the axis function creates the axis object in Matplotlib. Okay, so let's go into the Jupyter notebook and check what that exactly is, right? So let's say access class. So access class. Now this does not require you to import any other library from Matplotlib or any submodule from Matplotlib. You can directly say ax. Let's take a variable ax, and we'll do plt.access ax es. And we pass in values into it. I'll tell you what these values are. Okay. And these values which I'm passing into this construct over here is nothing but the left, the bottom, the width, and the height of the graph that you're trying to make. Okay, so I'll mention that also. It's the left, bottom, width, and height in that same particular order, right? So you want to be able to start from there, and you want to be able to have a bottom value, a width value, and a height value in same corresponding values over here. Okay, so this is just an empty graph because we are not passing any values into it. You can see over here that it starts from 0 and it ends at 1, right? So that is the leftmost thing, and the bottom over here. Again, it starts from 0 and it ends at 1 over here. So those are the values for the access class. Perfect. So we just checked the representation for the access class. Sorry. Yeah. Now let's check multiple plots. Okay. And how to do it. Now let's say that what happens if there's a situation where you need to represent more than one plot in the same figure. So just that you have one figure and you want to represent 2 or more graphs within that same figure. You don't want multiple figures. You want to be able to represent in the same figure. So how do you do that? So multiple plots feature in matplotlib helps you to do just that. Okay, so this is a feature in matplotlib which helps you to overcome this problem. Okay, so we'll be exploring 2 methods in multiple plots. One is add_axis method and the subplot method. Okay, so let's jump into our Jupyter notebook and see how both of them work. Right, so let's make a comment here. Multiple plots. And we'll be using the add axis method. Right. So we already have the imports over here. You don't need any other imports for this. So let's say that again, I want to create a figure with 5 inches of width and height of 4 inches. Okay, so let's do that. Let me make new fig over here and let's say plt.figure. Sorry. And you want to pass the fig size into it, which is nothing but the figure size. You want to pass 5 and 4 just as we require. And we'll create the first axis for the figure, for the first figure, for the first graph. Okay, so ax1, I'll name it ax1, and let's say fig dot, we'll be using the add axis method, so add_axis, and let's pass in some values for it. So I'll take 0.1, 0.1, 0.8. So this is just an example. You don't need to follow just this. You can use whatever values you want. And let's make another axis for the figure. Name it ax2. And I'll copy the same thing over here. And I'll be changing the values. 0.5, 0.5. I'll take 0.3 and 0.3. You can experiment with multiple values and see how it differs. This is just for an example, right? So now what I want to do is I want to add some data which I need to be plotted within the figure, right? So let's give it some data. Let's say ax1.plot, sorry, ax1.plot. So I'll be giving some random values here, 5, 4, 3, 2, 1, and y values 2, 3, 4, 5, 6. Okay. Okay, this is for the first one. And we'll make a copy of it and make the same for the second axis. We'll just change the values here. Okay. And let this remain the same. Okay. Now what will happen if we show this graph and see the output? Okay, so how to trace this error? So just see this, name fig size is not defined, right? So let's see what is the error here. Right. Does anyone know what is the error over here? If you were attentive on the previous, when I was explaining figure class, anyone wants to tell me what's the error over here? Right, Anmol, that's the right one. You have to put an equal to over here so that it takes in the values for the width and the height, right? So let's run it now. And yep, we can directly see the graph that is created over here based on the inputs that we gave. And you can see that there are two graphs over here because we gave in two parameters, and we can see that the output has confined those two graphs within one single figure. Okay, so that's what we needed and we got it. Okay, now let's explore the other method in multiple plots, which is also known as the subplot method. So let's see how subplot method is better than the add access methods. Okay, so I'll just show it to you. So this is the subplot method. Right. So let's give it some data. It's giving some random data over here. And let's create a figure object to make the figure. So plt.figure. Okay. And let's say that I want to add the first subplot. So plt.subplot. Subplot is the module that we'll be using here to do the subplotting. And I'll just give in some value or some random value. And let's plot using our plt variable. Let's plot it. Right. And I want to plot X and Y first. Okay. So let's pass in X and Y. And then I want to also plot the second graph that we said. Okay, so let's do that also. Pass in same ending value, and let's say plt.plot. Now I want to pass in Z and Y values over here. So initially we did X and Y. So now we'll do Z and Y. Okay, so let's pass it in that order. So Z and Y. Perfect. So let's see what it plots. Right. So what is the error over here? So there's a spelling mistake. So you just want to make sure that you put the right spelling. So there we go. We have two stuffs in one single graph, right? So this is one thing. plt.figure over here. To create the figure object, and we'll make a subplot over here. We say that it is it ends with 121, and then we have a plt.plot over here, which will take in which value to represent in the graph. And we also have a subplot, which is the second subplot, and we also pass in Z and Y values over here as an input, and we get an output based on that, right? So these were the few main things that you had to learn in Matplotlib. So we'll be ending this library with 3 examples. So we'll be covering line chart, bar chart, and a scatter plot. So let's quickly dive into Matplotlib, into our Jupyter notebook, and see how this can be done, right? So first we'll start with the line chart. What is it? So as you all know, line chart is used to represent a relationship between two data, X and Y, on a different axis, right? And it is plotted using the plot function. So you might have already seen it in the first example, but we will dive that again, right? So let's do line chart. Right. So we'll check the line chart and I'll give in some values as examples over here for X and Y values. And I want to say plt.plot. I want to plot X and Y. I'll give it as an input parameter. And this module over here, the plt.title, you can give a title to your graph, okay, to your figure. So just name it line chart over here, for example. And you do know that graphs, you can also mention legends in a graph. You can show which color represents which line in the graph if there are multiple lines. So we'll also be adding a legend over here. So you can do that with the legend submodule. Right, and just pass in line using this construct over here. And let's show the graph. Let's do plt.show. And there you go. So it passes these values, the X and Y values, into this plot function over here. And we also have the line chart, and we made the line chart as the title over here of the figure. And we have a legend which shows over here. It says that this is a line. We gave it a name line, and it represents blue color, and you can see blue color over here. So plt.show shows the output, right? So let's check the next one, which is bar chart. Okay, so how do you do that? So a bar plot or a bar chart is a graph that represents the category of data with rectangular bars with lengths and heights that is proportional to the values which they represent, right? So this is all basic math stuff. It's just representing data with rectangular bars. And the bar plots can be plotted horizontally or vertically. So it is your wish. You can do it either ways. And a bar chart describes the comparisons between two discrete categories, right? Not two, many discrete categories, right? So it's your wish. It depends on how many categories your data set or your data has. So, and it can be created using the bar method. Okay, so let's see how that can be done. So bar chart. So let's check bar chart. So let's give in some values. These are some random values that I want to give. Now let's say plt.bar. So bar.bar is the method that we use for the bar graph. We saw it in the previous slide. And let's pass in X and Y, because I want to create a bar graph using X and Y values here. And let's say I want to give a title to this graph or this figure. So title, I'll name it simply as bar chart. And I want to give it a small legend saying bar, and use this construct to give the name of the legend and just do plt.show. So you can see the output. Right. So we have successfully created a bar chart using X and Y values. So we'll just check one example here. So 4 and 12. So where is 4 and 12? 4 and 12, right? So you can see it here, 4 and 12. 4 and 12 up, right? Let's see 3, 3, 3, and 3 is between 2 and 4. So you can see that it has plotted it over here, right? So 2 and 5. So where is 2 and 5? 2 and 5, right? So it takes in all of these values from these two lists, X and Y, and passes it into the bar method over here. And we pass in X and Y over here. It takes in a sequence. And we have the title and we have the legend. You can see the legend over here, which is bar, and it represents it using the blue color, which is the entire graph. And we show the graph using .show, and we have an output over here, right? So this is for bar chart. And to end things off, we have the scatter plot. So what is a scatter plot? So scatter plots are used to observe relationships between variables, and it uses dots to represent the relationship between them. Okay. So in the previous graphs, in line chart, we saw that it uses lines to represent your values, your x and y values. In bar charts, we saw it used rectangular bars to show your values and give you a visualization of it. But in scatter plot, we'll be just plotting dots at that particular x and y value, and we'll be creating a graph out of it. So that is scatter plot. And to do this, the scatter method in the matplotlib library is used to draw the scatter plot. Okay, so let's quickly check that one also. Right, so we have a scatter plot, and let's check how to use the scatter plot. Okay, so similar to the previous one, let's give in some random values. So I'm giving random values just for demonstration purposes. In reality, you'll ideally be giving your own values. Okay, so we'll be using the scatter submodule over here, and just like the previous one, we'll pass in our x and y list into it. And let's say that I want to give a legend to this graph. So I'll do plt.legend. And you need to pass a value here. So let's say I want to call it A. And I want to give a title to this chart. So plt.title. Given some title, let's name it simply scatter plot or scatter chart, whatever you want. So name it chart. And let's do plt.show. So let's see what happens when we execute this. So there we go. We have dots which represent our individual x and y values. So let's see where are the dots. So 3 and 3, right? So 3 here, 3 over here, 3 is between 2 and 3. We have this plot. So 12 and 4. So 12 is here, 12 is here, and it across 4, right? So we have that one. So let's check another one, 1 and 2, 1 and 2, right? So 0, 2, 1 is over here, 1 and 2. Let's check one last one. Let's check 2 and 5. Okay, 2 and 5. So 2 and 5, right? So we have a plot here. So we see that we've given some values into x and y as lists, and we use the scatter submodule over here, and we passed in both lists as x and y, and we plotted it over here, and we also gave it a legend. We named it A. You can see it here, and it's represented using blue color, which is also the color which is used over here to represent the dots. We gave it a title. We named it scatter chart, and it named it over here for better representation. And we used plt.show to display the final chart, right? So this is scatter chart in matplotlib. So I want to end this this particular session with a quote from John Elder. And he says that learning from data is virtually and universally useful. Master it and you will be welcomed anywhere, right? I for one, I do totally believe in this quote from John. And data is everywhere, and companies that have huge tons of data are looking for people that can derive some useful insights out of their data, right? So I hope this session was pretty useful for you. And I'll be handing it over to Anmol. He'll be showing you how to use all of these 3 libraries that we learned in day 1 and day 2, which are namely pandas, NumPy, and matplotlib to create a model. We'll be seeing some data cleaning and data analysis in his session. So once that is done, we'll have a final Q&A session where we can clear all of your doubts. So over to you, Anmol. Thank you, guys.
Yes, Pranav, it was an excellent explanation. Guys, as Pranav said, when we have so much of data, we need to we need to properly organize it properly, and then we need to perform analysis. So using the three libraries that we have learned yesterday and today, we will just be performing a small data analysis on the data set. I've shared the link in the chat. Please do download it. And I'll be sharing my screen now. Okay. Okay, I need you to go back to your Jupyter environment, and I want you to upload your downloaded data set from your folder, and then create a new notebook. If you guys are ready with your data set and the notebook, please type in yes. I will not be taking much of your time. It'll be a small analysis just to get an idea on how to use all these three powerful libraries. Could you please repeat what was done? Vishwa Patel, I want you to download the data set given in the chat box and create a new and upload it to your environment and create a new notebook. Okay, you guys are ready. So as you know, the data set is a zip file. So we'll have to unzip it. So we'll import a library called a zip file. And then we'll import whatever we have learned. Pandas as PD, import NumPy as NP, then import matplotlib or pyplot as PLT. Pyplot. Yeah, so just run all these libraries. And now let's load in the data set. It's a FIFA football. It's a data set about various footballers taking part in the FIFA. So let's load that into a variable called FIFA. And we do that by using pandas read CSV. And then we take the name of the data set. And we need to mention that it is a zip file. So we mention it as compression is equals to zip. And then run this. Now we have imported the data set into our notebook. Let's check the first few lines of the data set by calling the head function. Here you can see that, here you can see that there are multiple fields like FIFA ID, player URL, short name, age, date of birth, nationality, club, and various other attributes. We have various players here like Messi, Ronaldo, and all. And you can see that there are 104 columns. So this is quite a huge data set. Let's understand more about this data set by calling FIFA.info. Now you can see that it tells that there are around 18,000 entries in this data set with around 104 columns. So you can imagine the amount of data cleaning and analysis you have to do to handle such data sets. Yeah, now let's do FIFA shape. This basically gives the number of entries with the number of columns. And let's store all these columns into a array called features, and let's use NumPy here. NumPy.array, and then we'll call FIFA.columns, and then let's print these features. So you can see these are all the columns that are present in the data set. We have club, the attacking skills, goalkeeping skills, all these various attributes for a player. And now here you can see that, okay, let's, player URL and so FIFA ID are not very much required, So let's drop these fields by calling FIFA.drop, and let's pass in the feature names. And player URL. Since these are not much required, right? When you perform analysis. And then we'll be calling access equals 1. Then in place. That's true. So when access here means that if it's 1, it is telling that we have to drop a column. So if it's 0, then it means that we have to drop an entry. Let's run that, and let's again print the FIFA.head just to understand that those two fields are vanished and now they are not there. So this is how this process is called data cleaning. So you only select whatever features you want, and also you clean your data. And notice that in this data set, there are multiple NaN values. These are not a number values. So it's not possible to perform operations which have these NaN values. Hence, to remove those NaN values, we can just replace them by inserting 0 in that place. So let's say FIFA.replace np.nan, and let's replace that with zeros. No, I think it was Jan Obalak, right? Now you can see that all these are now changed to 0 instead of NaN values. Now, instead of putting zeros, you can also put the mean of the various other entries. That would make your model much accurate. But again, those are little complex problems. We can use something called imputers, which will not be handling right now. Let's just stick to zeros. And notice that the number of columns have been reduced to 102 from 104. Okay. And now let's see how we can select some features from this huge data set. All right. Let's call FIFA. And let's say I only want to see something called nationality. I saw that attribute here. Yeah. let's say I want to know which players are from a given nationality. Then let's see how many countries are participating in FIFA first. That's called value counts. And you can see that there are around 1,667 players from England and so many other countries. And we can see that there are 162 entries, which means that there are 162 countries participating in the FIFA. And all of these are of type integer. And since these are 162 in number, let's just simplify our process by reducing this to only first 10 entries. Now you can see that there are only 10 entries, the top 10. And yeah, if you want to know the keys of the indices, then you can just see that all these countries belong to the top 10. Now let's use matplotlib by calling plot plt and then figure. Let's give fig size as something like 8 and 5. Let's do a bar graph. We'll call that bar. And okay, let's say I want the x-axis to be the name of the countries and the y-axis to be the number of players from it. So we'll just do a list and we'll call in FIFA of nationality. And then we'll call value counts. Let's just do it only for the first 5 entries, first 5 values, and let's give the names, right? We need the names, so we'll give keys. So this is our x-axis, and let's give the y-axis as list FIFA nationality value counts. And, for the first 5. For the first 5. And let's just tell that the color of the graph should be something like let's say blue. Yeah, so let's run this and we see that we get the first 5 entries. We see that about 1,700 are from England, and we get the graph here. Okay, now we'll just do FIFA to know the indices. Dot value counts. Notice that if I don't give anything here, it will be taken as 0. Then we'll call dot index. So we have the country names as the indices here, and they are of type object. Okay, now let's suppose we want to understand or to understand more about the salaries of various players. So we'll just create player salary variable, and let's take in only the required features, such as we only want the short name, I think it's called. Yeah, it's called short name. Then we'll just take in the salaries. Okay, it's called wage. That's short. Okay. Yeah. Now let's just print player sal dot head, and we see the list of the first 5 with their wages. Now let's apply sort function here. Okay, let's do player salary equals player salary dot sort. I think it's called sort values in pandas. Then by as a wage. This is in euros. And then we'll give that we want in descending order, right? So we'll give ascending as false. And then we'll print player salary dot head. And you can see that these are now sorted in a descending order fashion. Now let's just say that I want only players whose nationality is me. Now we get a list. Okay, it says all false, right? So then we let's just store this Germany as FIFA of FIFA nationality equals Germany. Then we'll do Germany dot head. Now we get only the players whose nationality is Germany. The reason I'm showing you all of this is because this is how you get the most important, data from your huge data set. So accessing is a very important task to perform your, operations on your data set. And similarly, you can make multiple variables like shooting, player shooting skills, and you've taken the FIFA, and then you've taken the names, right? You want the names to be displayed along with your attributes, and then we take in the shooting skills. player shooting short names. Okay, I think it's called short name. Okay. And then let's again we can sort this player shooting dot sort. It's called value sort values. We want to sort it based on the shooting skills. And then let's say the ascending is false, because we want the highest rated player. And let's just call in head to print the first values. Now we can see that Ronaldo has 93 skills of shooting skills, and we get the rest. So in this manner you can perform, various data analysis methods and make your data pre-processing, suitable enough to perform various prediction models or whatever the ML models you want to deploy in your data set. So using these three libraries, pandas, NumPy, and matplotlib, you can understand your data more better and also organize it in a good manner to use it for further use. So yeah, this was a simple application. I wanted to make you understand where we use such libraries, make use of it. So this was it, the model training. We will be covering more sessions in the future, talking about the ML models. But right now, we just covered the data science, data cleaning part of it using the three libraries. I hope that you understood these concepts and took away some, good insights from this bootcamp. And hopefully you can apply these techniques towards building your model and making some wonderful projects. So I thank you all for attending this session. Yeah, thank you. Over to you, Ishan, if you're there.
So we'll also be sharing our LinkedIn profiles on the chat box. So if you found this bootcamp informative and if it helped you, kindly endorse us for our skills. It would mean a lot. So we would do that right now.
All right. Thank you, Pranav and Anmol. That was a wonderful session today. And 12 of the audience, I thank you very much for taking time and patience to attend this 2 days of Python Bootcamp. Hope to see you again in Web Development Bootcamp that is going to be held from Monday onwards. On Monday, it's going to be from 12 to 4, and later it's going to start earlier. So, given that we had 2 days of Python workshop, I'd say that the amount of content that was delivered by your friends and GDSC members later was very useful. I presume they're useful, and I assume that you all would have, inculcated it extensively. And therefore, I hope that you practice on it more and more. You can go over to Kaggle, get some data sets, practice over it, and sharpen your skills upon data science. Hope that you find the content useful, and hoping the same participation and exhilarating participation again in upcoming sessions. So Pranav and Anmol and Himanshu, thank you very much for your session, and Vishwa says details about web bootcamp from tomorrow. Yeah. So the web bootcamp is going to be offline totally. Monday is going to start from 12 p.m. Through 4 p.m. and Tuesday is going to be from 9 to 4 for 10 days. Let me tell you, the content for web bootcamp has been prepared totally from A to Z, and the speakers, Mr. Ishan, is really excited to start it. So Vishwa, I'm looking forward to meeting you on Monday, and let's wrap it up. Thank you everyone. Have a good day. This is Sumit Anand. It's October 17. Have a good day and good night.